Hey guys, here's our next project for the day. The customer dropped this off to me and asked to see if I could make 8 of them, 8 more of these things. I said, sure, bring it on by. And what are these things? These are called hook nipper, and they are used in conjunction with 8 more of these per machine. What they do is they work on the railroad track type machines. This particular item will be on the machine, and these will bury into the rock. I forget what they call that, but into the rock, and they will reach around the railroad tie and grab it and lift it up while the machine sets the spikes for the nails on the machine. Then these will let go, they will raise back up, and then we'll move on to the next one. And so I'm not too familiar with that. I've seen it on some videos and things, but you know, a customer was reaching out to see if I could cut these out for him, and sure enough, we got the material. This is 1 1/4" 572 plate. These are initially a cast material. Now I'm hoping that the 572 will be strong enough. It should be strong enough, but the wear characteristics, hopefully they're strong enough for it. But on top of that, as they did here, we see that they added some hard surfacing material, so we're going to be doing the same thing. So this is going to take multiple steps, being that we have a hole drilled here and here, got a grease fitting here and here, so that will take some machining or some drilling at least. And this here has a bevel on both sides, and the bevel is to push the rocks out of the way as they're plunging and attempting to grab onto the tie. So that will be something we'll have to do as well. And here it's got a long taper this way, long taper that way on both these ends here, so you can kind of see where they bevel out. This is a piece of carbide that they have on the end. It looks like it was brazed onto a piece and then welded onto the end. That I have not been able to source yet, so I'm gonna have to think of something about that one. I was looking at some other photos of these units or these things, and they don't have those. I guess this is an upgrade to make them last longer, which is nice, but I've been struggling to find that piece. I reached out to an auger manufacturer here in Texas, and I was trying to figure out where they buy these little pieces, and he didn't want to talk about that. So okay, so I'll have to keep looking. So anyway, what we're going to use to cut them is my hands. I'm kidding. Actually, I reached out to CN Seamless. I know you're familiar with them. I'm sure a lot of videos have been coming out lately of these machines. They're incredible cutting machines. They work really great as far as being a robotic type CNC machine. And so I talked to them at FabTech last year and was able to see about working together with them, and they agreed. So I'm pretty excited about using this unit. I also, one of my last videos, I think on a short, I had one of these also that I was showing that I was cutting a piece out also for the railroad industry. And so this is going to be a more detailed unit on how to cut out this shape all at once. And so stand by while I get all this set up, and then we'll get to cutting. All right, so here's a unit kind of set up. It is got an electromagnet that is powered by 110 power. In this case, the connections for oxyacetylene. It does have an option for oxyacetylene or a propane, whatever type of gas you use. I would imagine you have to change the tips for propane though. But this also is offered in the plasma cutter module. So this comes out, this arm comes off, and it attaches for a plasma cutter on the end. But in this case, as I mentioned, it's set up for oxy fuel. I have some quick connections here that I will be making an announcement later. I'm trying to sell these particular ones. These are very durable, even more so than the more popular ones right now. So hang tight for that. But moving on with this is run via a tablet, and I don't know if you can see the display, but it has a grid pattern here, and you are able to program this shape in several ways. Either you can import a drawing, or you can use a feature which is called point to point, which will allow you to map these individual points as you're going around, and it'll start creating it on the surface here on the tablet, and you can mimic the same item. Now in this instance, I can follow these patterns with this here and mark the point to point. But what I'm going to do is I'm actually going to trace it onto the plate first, so I can show you a little bit better as to why I'm opting for that route. So let me go ahead and trace it out, and I'll set it up for the point to point feature, and we can go from there. All right, so now I got this pattern laid out here, and so to use the point to point feature a little bit more effectively, it has a line option, point to point line, and an arc option. And so in order to get as accurate as I can, I decided, let me draw this out. That way I can by hand mark the start and stop points of these said lines to arc transition. And so to say, in case I'm going to make a line and I want to start my arc, I'm going to want to mark the beginning of that radius there, right? So the beginning of that radius there, the middle point there, and the end of that radius. And so very similar, it's still going to create an arc because it's going to transition from that direction to this direction. So I have to mark a middle point and an ending point. And so as I continue to mark all the way around, it'll transition from arc to line and line to arc as I go around this pattern. So let me go ahead and mark these out and see if I can make more sense of it as I'm using the machine to mark out those lines. So let me go ahead and do this here. Okay, one more over here. Here's the middle. This is with the end and the end. Right there. Okay, so here are the beginnings and ends and middle points of the arc. Line to line, arc, arc, and such. So let me go ahead and set the machine up to follow that pattern. Now that I got this machine pulled out and set up, this comes with a stylus pointer that is tucked away under here with a little magnet here, and that slides onto the tip of the unit, so you can get real accurate marks as to where you're positioned at as you follow this around. And so one of the difficulties right now for you guys is that you won't be able to see this screen so well. It's very, very dark, but I can see it. And so there's a button at the bottom that says design, and then it has a point to point feature down here at the bottom left. And so the torch automatically knows where it's at as you move it around in space. And that's good, and that as we follow the pattern along and make these marks, you don't know where it's at, so it remembers where to follow when you cut. So in this first instance here, I'm just going to go ahead and put this down. I will make my starting mark right in here, and if you look closely, that is right above that first mark at the end of that radius. So in the point to point feature, I'll be able to make the path to say, and here I will make a line, and so that would be the start point that I mark, and the end point will be right there. So I press end point. Now I'm going to make an arc. So now from that point, it's going to ask the middle point, and I will move it to right there, and the end point, and so on. Another arc. Middle point. End point. Line. Line. So, as you can see, hopefully you can see, that is our drawing right there. So now, to test run it, I'm going to go ahead and set it up so we can pretend it's going to do a cut, and you'll see that it'll follow it around. Okay, so the next step is to place where I want it to be, so that way it knows where it's at. I've already check marked that one and those two, the axis point 1, axis point 2, and the origin. So that's good there. Now I check the material, steel, 1 inch to 2 inch range, the type of tip I'm going to be using, the delay and the pierce delay, the cut feed rate, those types of things. So confirm that, and pretty much it's ready to go. I don't know if you can see that design in there. So now we'll hit run. We're just going to do a test sample. I will set it at the desired height that I want to cut at. Of course, this is, let me go ahead and take this off. Well, I'll leave it on so that you know how accurate it is. So I will get it to the height that I want right there, and once I hit start, it'll actually go to where it wants to start from. Starts over here for some reason. I wish we could kind of place it where we want to place it, but not at this moment. So now that you see that there, I can lower it to the desired height that I want it to pierce at. So the preheat temperature will be right there. Being that this is an outside cut, it's going to cut from the outside first. Once I'm ready to go, then I will hit pierce. Once I see that the material is hot enough, I will hit pierce. It would raise up, pierce, then go down, start the pattern. Now I'm going to speed up the pattern so you can see how it follows that. There you go. So of course you see a lot of glare, unfortunately. There's a lot of sun out here. There you go. You might be able to see that a little bit better there. But now it's time to hook up the torch. So let me get set up for that. Actually, I don't know if I'm going to do a test run. I'm just going to let it preheat. not just speed it up or slow it down as needed. Got a little hang up on this one spot here, may not fall out. Let me see. All right, let me see, knock that out. Yeah, that's pretty good. Could have probably slowed it down just a little bit more, but that is really good. Little cleanup, very nice. All right, only 7 more to cut. All right, guys, so you may not be able to see it, but I've repositioned this machine to where I can cut layers in that way, that line, and that way I can get 6 this way and 1 more over there that way afterwards. And so if you can see the pattern here, it's kind of hard to see because it's so dark, but I've set it up to where now there's 6 is going to cut in front of me in this direction. And so now it's a matter of relighting this torch and setting it to start. So let's go ahead and do that. All right, now that we got it running, let's go ahead and set this to run. And I'm gonna move it to where I generally want it, but now I need to set the torch height. That's about as high as I want it. And I'll say start. So it's gonna move to its position, should be over there. Yeah, I'd like the preheat to be a little lower, so I modify its movement. Now we just need to wait for it to pierce. So let me wait for a second for it to get hot and go look at it. Give that a shot right there. Whoa, no, that's crazy. I think that was my fault. Yeah, I don't want to shake it. All right, so I almost got them all. It turns out I had a little bit of a boo-boo there, and one of my starts, the tip started getting contaminated and dirty, and it was cutting super wide, so I canceled that cut. And so it was best just to scoot it over and restart it. Now, one of the things that I noticed here is that it doesn't nest real good, only because I set the spacing, but I wasn't quite sure how close to get it to each other. So that's partially my fault. Now you may say, well, that's a waste of material. But when you consider that the retail cost of 2 of these is worth this whole sheet, there's plenty of time, or plenty of material to cut more. And so for those that say, oh, you're wasting material, well, not necessarily. So now I just got to move it over right here to cut one more, and then we will be set with our 8. And then from there we can move to the next steps. So things are looking really good. I'm pretty excited. These cuts are coming out pretty nice, considering, you know, this is my first time really using this thing for such a big project. Look at that. Pretty good cuts. Pretty good cuts. So one of the things that I'm still learning is torch height off of the pierce and the pierce delay. You know, it varies, of course, depending on the thickness of material. So I was just guessing. The range that this was going was between 1 and 2 inch, I believe, the settings on here. So, you know, you got to fine tune that. But other than that, you know, it's not bad. It's really saving a lot of time, a lot of effort. Even Torch Norris couldn't cut this out as good as this. So let me cut that one other one, and then we can move on to the next step, which I think will be the drilling, because we have beveling to do, a lot more heat input. So let's drill them before we put even more heat into it. All right. Okay, so one of the things that I didn't get to show you guys is that once you place it on, set its origin to say its starting point, let's say right there. Now I can move this torch around to see if it's actually going to fit in the material. See, I can move it like this, all by hand. See, make sure it fits. So you can make a piece of whatever drawing it is that you have, you can kind of place it within whatever odd shape of material you have. So here it looks like it's going to do well. I know you guys can't really see. Oops, timed out. And now I know it'll fit. So now I can just light it up and get ready to cut. Man, that is fantastic. Look at those incredible cuts. Nice. You know, as with anything, you have a couple that are a little bit off here and there. Had one that's kind of a little wonky at the bottom, but you know, that was because of me not knowing the setting and the speed. But right towards the end, things started looking really good. Real nice crisp cuts. This edge real nice and sharp, meaning that I didn't overheat the plate and round off these edges. So that came out really good. Okay, that's gonna do it actually for me for this afternoon. Got some dinner planned, so gonna go and get ready for that. But we'll start again tomorrow with drilling the holes, and then possibly just beveling all these up. It should be easy enough to do tomorrow. I don't know if I'll do it by hand or if I'll do it with a track torch. We'll have to see. Maybe I can clamp them up, but we'll see what tomorrow brings. but this is looking pretty good, and pretty happy. So all right, see you guys in a blink. All right guys, so this came out incredibly nice, considering for you know, being able to just do the point-to-point feature. They are nice. Yeah, can't complain there. Look at that. Beautiful cuts. Okay, so obviously next step is to clean all these up, and so at that point I will then transfer this hole to these, get them all drilled out. So let's keep on trucking. All right, now that I got these guys cleaned up, next thing to do is to obviously drill out these holes. And so what I'm going to do is just going to lay it over the top, line it up as best I can, then use a piece of round bar with a hole drilled through the center as a center punch. I'm going to use a 1/2 inch center punch or transfer punch. One side will be this size and the other side will be that size, so I'll just flip it over and use the same punch, and that way I can get them pretty straight. So let's go get this machined. Excellent. So this little piece will work. One side here, the other side over here. A transfer punch, 1/2 inch transfer punch, and that should do it. These holes aren't exactly critical to themselves as, you know, something machined would be. So, you know, I don't know that I necessarily have to clamp it down to get this transfer punch. This is on a different axis than this. This is a hydraulic cylinder actuating it. So, yeah, pretty close, right? So this should work. All right, let's get all these punched out. Okay, so we're going to use an 1.5-inch annular cutter. I centered it up as close as I could on there. Granted, this is not the best way of clamping it down, but that's all I have because it turns out I don't have the right vise for this. So you got to do what you got to do, right? And so when I put all these in place, I am going to have to adjust it a little bit back and forth. This little pin does have a little bit of wiggle room, as they all do, but so long as I can get that pretty centered, it's going to be fine. You know, like I mentioned, this and this don't run parallel shafts, so it'll work. From a machinist standpoint, this is probably murder, but this is going to work, right? And if it's going to work, it's going to work. So let's go ahead and get that drilled out. I'm going to do all of these first, and then we'll reposition to do that. All right, so these are coming out really nice and accurate. That's what I like about these annular cutters. They're on the money, so not bad at all. Pretty nice cuts. Okay, we'll just keep going because, you know, don't want to bore you guys with a bunch of drilling. So let me cut these up and go to the next step. Just got more work in that, and then this old guy decided to take a dump on me. Just busted a cylinder. The seal finally gave out as I was unloading the auger, so that stinks. But just add another ball to the juggling. Can't stop right now. Gotta keep with my project. So I'll get to it soon. Okay, so I got all these guys drilled out, which is looking really good. Very nice. Now the next step is to, of course, put these grease zerk fittings. So I went ahead and changed this out here. Oh, sorry, this here to the use a regular drill bit. I'm just gonna stand them up in here and drill them out. So let's do that next. Okay, so now that I got those all threaded and tapped, next thing to do is to cut the bevels on these. Got the bevel here and the bevel here. So I figured I'd get my track torch and set these up all as one piece, all of them in a line. Of course, I'll adjust them all as necessary, and then just run this one time, preheat, cut, preheat, cut, and stack them all up in this way. That way, do it all at once. So I think that's what we're gonna do. Then I'll just flip them over, do the opposite side, and then we'll do this side here. So a couple of steps that will, take a little bit of layout and make sure that they're straight. But it is what it is. That's how you get these done as efficiently as possible. These bevels here are not gonna be fun. It's gonna take a bevel this way, and then opposite side as well. That's gonna be an interesting one. So let's get these done first and get the easy ones out of the way, and that'll help preheat some of this. Maybe it'll make it easier to do those. Who knows? We'll find out. All right, let me get these straightened out or put in the line. All right, so I had a change of plan. Instead of doing mechanically with that by setting up these all to cut in one row, there's too much effort to get exactly right, and so I think I'm just going to do all these by hand. And what I'm going to do now is I'm going to take a basic measurement from here, from this edge to right in that area, so it looks to be about 1.1 inches. Make a mark here to 1.1 inches, and of course just mark a line there and mark the center. Just bevel these by hand. That way I can roll it and flip it a lot quicker and a lot easier, and just save a lot of time. I know a guy that can cut pretty good with a torch, so I'll have him come out and do it for me. That's a joke, but anyway, it's just so much easier than to try and set all this up, and I should have somewhat good success. I may have some serrations and things, but that'll be fine because it's gonna be covered with a welding hard surfacing rod. So I think that'll be quicker, so let's go that route instead. Let me get this set up. In order. Okay, so on these guys here, I kind of made some reference marks to go off of, even on the sides back here. So as I torch, I'm gonna kind of shoot for that angle there. I would like to leave a landing here, maybe about 3/16 or so. That way we can put some weld on there with that hard surfacing rod, so it doesn't really have to be that critical or that accurate. The whole goal is for it to be pointy enough, of course, for it to press into the ballast material or the rock. So this is something for me to just eyeball. Now naturally this is just regular permanent marker, and that's going to burn off, but once I get going, I can kind of see where I'm headed as far as in line, and I should be able to torch it, hopefully successfully enough to where it's straight. And it doesn't really have to be all that straight. I mean, it's we're not making pianos, so a bevel is better than nothing. So let's see how much success we have in the first couple. Might get better after we get more of them done, but let's see if we can shoot for all of them good. All right, let me get the torch set up. pretty good. Okay. Oh yeah, that's gonna do it. All right. Yeah, I'll do these babies by hand. A lot easier that way. Excellent. Only 7 more to go. So far so good. I marked a line right here as to where the angle should end. Most of them are pretty close, and so that's not bad. Some are a little lopsided than the other, but that's all right. It'll still create a wedge. You know, looking back, I should have done this one first because the bevel would have already been created here and here. And I could have still used this corner edge as my guide for doing that. So now I'm gonna have to struggle with figuring out where my bevel should start, because it's gonna stink trying to start off an edge like this. So one of the things you learn as you're doing them. Either way, gotta keep going. Okay, so here I'm gonna have to kind of guess where my angle is. Oh man. Yeah, that's gonna stink. Oh, that didn't work. Maybe something like that. Man, this stinks. What did I do? Yeah. It was sharp on the angle, but it's not pretty, but that end, the grinder can fix that and fix that. Let me see if I can do it better. Oh yeah. Actually, now that I'm here, I gotta put a bevel on this too. That's gonna be a good one. Okay. Can only do one side but not the other. I'll need to do one side and then set up to do the other, because the other side, my torch tip is too far away and it's becoming very wavy. Not good. Now I see exactly why they went to a cast piece instead of a formed out of plate. Very labor intensive. Now if you have a machine that can bevel and do all that, like a big plasma table or something, that'd be fantastic. But I don't yet. of all the steps, I think this is the hardest part. All these cuts, the drilling, you know, the CNC cutting all that out, that's easy. Drilling's easy. This is the hard part. And unfortunately, they're coming out. They'll work. And the grinder will make them a lot prettier, which is fine. But, you know, I normally like to leave my finished cuts pretty clean, and I'm not going to be able to this time. I know, somebody call the ambulance. Excellent. So that turned out rather well. These do need a little bit of a cleaning, so I'll hit them with the grinder. Let me get out of the sun. One of my first ones came out pretty bad, but I mean, they're still gonna work fine. But these came out pretty good. So nice little bevel. That's a long bevel. Look at that. That's crazy. So a little cleaning, then we'll start stick welding the hard surfacing on here. Okay, so the rod I'm going to be putting on here is Studi number 35. Studi makes a very good product. This is a number 35 is a metal to earth wear, so some good impact resistance, and so I will be welding it up in here. One of the things that I like to try out is this piece here is completely full of hard surfacing. And while that's great, it does, I don't know how well they hold up, and I only say that because sometimes things like this tend to wear out or break off. And what I've experienced before is that sometimes if you put them in the correct spots, they will wear just right, and they will continue to keep that angle or that sharpness to say. So they're almost self-sharpening, and they will continue to hold up and do well. So that's what I'm going to try and do here. I'm going to try and weld around the perimeter, weld around in here, this backside as well, this triangular backside, and this gripper part in here. That'll be solid, but it will just be a perimeter around here. And as the rocks tend to wear through here, it will create its own sharpness and continue to be able to pierce into the rock. So if they start to wear too much or to start to become an issue, well, then you can just go back and fill them in. But these, I've had good experience with that before, so we're going to do it that way. All right, let's keep going. Okay, so I don't know how I feel about that perimeter and then the rocks rubbing on here and creating a self-sharpening effect. Normally what happens when you are trying to put hard surfacing, you want to put it perpendicular to the travel of the bucket or whatever tool is engaging the ground. So in case you have a tool going in this direction, let's say a bucket that's digging, and you have the teeth like this, and people want to build up on the inside of the bucket, you want to put the lines or spaced out lines in line, sorry, perpendicular with the travel. Yikes. That wasp is gonna get me. Perpendicular to the travel, so that in between the lines there can be some mud or dirt that creates a cushion for it to smooth right over. So looking at it laying down, let's say the travel is that way, that general direction, you put a weld and you put another weld about 1/2 inch away or 3/4 inch away, like that, and these areas here will fill with dirt, and they'll create the cushioning effect for it to slide back and forth, and it'll protect your bucket material, you know, however thick it is. But what I was trying to do here is I was trying to create a situation where let's say you weld on the bottom and the direction of travel is this way. It would continually sharpen itself depending on how wide the weld is. It will continually sharpen itself, and you will have a sharp edge of material. It'll wear away the thin or the softer material, but the hard surfacing will be the hard edge, and you'll always have a sharpening effect. That has worked very before for me very well, very successfully, but I don't think I want to do that in this situation. And so I'm kind of torn as to which way I want this to look. I don't know if I want this in this line, these lines this way, maybe run 3 lines and let the rocks gouge in between and sort of create a self-sharpening effect still, or go perpendicular to the weld or the direction, which would be something like this, and create pockets for it to smooth right over, similar to here, like that. Right, so it's a tough call. I haven't decided yet, but you know, they on this other one, they poured a bunch of goop on it. Didn't even get this bottom half right there. That's the cast material. All this area, they just gooped a bunch of stuff on there. And you know, granted it'll last, but we want it to last a really good long while. So let me chew on that a little bit. I still got, you know, all these to go. This is still my first one, so I'm decided on which route to go. I did put some buildup back here, so that's done. This inside is done as well, right in here. And so now it's just determining, do I want to create pillows between so that it smooths right over, or do I want it to continue to sharpen itself? I tell you what, I'll do this horizontal like that. I should have done that before I ran the center one, but the next one you'll see it look a little bit better. I'm gonna run these this way, and that way it skips over and creates a cushioning effect. Okay, let's at least try one and find out, right? Okay, here we go. Okay, I think I like that pattern. That should work. I mean, it's gonna create the little cushioning effect, and it'll just glide over that, and it'll last. So, like I said, I got this built up. These are pretty deep, so that should work out pretty well. So, I think I'm just gonna fast forward all you guys and just do all this, because there's no sense in just watching a bunch of stick welding, and then we'll get it done. Sorry, I got the hiccups. So. Let's get her done. All right, well, that's the last one. It's about as good as I can get it. They're hanging over there for paint. I guess you can't see over there, but they're all done. That's a crazy amount of work. So I'm sorry I didn't show too much of the actual welding. This is just boring welding. I ended up running like 3 passes over each run of the Studi rod. As I mentioned, they're only 1/8" rods, so they're about 3 passes or so on top of each other, here, and of course around the perimeter as well. So good hard rod. It should last a long time. I'm pretty excited to see how long they last. I should try and see about stamping them or something, maybe to see how long they do stay on the unit. But in any case, these are done. So long day for me. I'm pretty tired, and I need to go inside. We got to deliver these guys tomorrow. So thanks for watching, and I guess we'll catch you guys on the next one, and thank you for the support.